Hi everyone, welcome back to my YouTube channel. Today I am going to discuss with you some details about site investigation and soil exploration. This is the most important part of a project. The objectives of soil investigation, it is to determine the nature of the soil deposits. It is to find out the depth and thickness of various soil strata and their extent in the horizontal direction and in the vertical direction as well. Soil profile, you might have heard about soil profile or bore log. It all comes under this, where you go for investigation on the different soil layers in the ground. Soil, not only soil, rock and other geological materials. So the third one is related to the groundwater table, and the fourth one is related to the engineering properties. I have mentioned to you about soil characterization, and in one of the previous videos you can check in my YouTube channel in the playlist. You can see the different methods adopted for finding out the engineering properties and other soil properties which will control the design parameters. Okay, so in situ soil properties are determined using field test. So this soil investigation also involves obtaining the soil and rock samples from the various strata for further studies. This is a general overview of different geotechnical investigations. There are direct, semi-direct and indirect methods adopted here, and direct methods are trial pits and trenches, and the semi-direct methods are borings. Machine are used for boring, so we will see that one by one. So auger boring, wash boring, percussion drilling, rotary drilling, shell and auger boring, all these are different types of boring which are termed as semi-direct methods. Then there are indirect methods. Geophysical methods are there, seismic refraction method, electrical resistivity methods, etc. And sounding or penetration methods are there. Standard penetration test is one of them, and static cone penetration test and dynamic cone penetration test. In the direct method, you can see here that typical trial pit. Okay, so it will be collected from this for different testing. Visual inspection will be done, and by observing the soil, the site engineer the geotechnical engineer can easily tell about a general characteristics of the soil. So this is mainly used for minor structures like single-story buildings, like residential buildings, etc. Now let us see the semi-direct method. This is most widely used method. So boring machines or equipments are used for this. It is done for 3 to 5 meter depth with hand operated machines, and mechanically operated or diesel engine operated methods can be adopted for a depth of 50 meter. These are some of the drill bits used for boring. Machine operated augers are also widely used in stiff or hard rock samples. So this is another view of auger boring. So shell and auger boring. So in this schematic you can see that there is an equipment which is called a shell. So this will be collected in this. The geometer will be collected in this, or even filled into this while boring, and it will be taken out for further action. So this is wash boring. You might have seen this several times. This schematic shows that the wash boring is a very important methodology adopted for collecting the soil and rock samples. So water will also be associated with this. Water uh, will be used for this type of purpose. There may be bentonite slurry also used for this kind of boring. Percussion drilling, this is for hardcore rock samples it is used. For stiff soil also it is used. Okay. There will be a cutter or cutting machine will be there. So in this the geomaterial will be collected and taken out. And rotary drilling is also used for rock formations. If the ground is rocky formation, so rotary drilling is used. Rock cores are actually used for different tests. This is another type of drilling. This is rotary drilling. And these are some of the parts of wash drilling system. You can see here there will be cutting shoe or also available, and there are cutting core or drill bits are there. So these are used for hard or stiff soil for rock formation. So a depth of exploration is, or significant depth is found out using the pressure bulb. So generally it is used for mega projects, and there are some guidelines for depth of exploration, even boreholes. So these are some of the schematic, shows you a clear explanation of that. For isolated or spread footing, the depth of exploration is 1.5 times B. B is the width of the footing. For adjacent footings with clear spacing less than 2B, so the depth of exploration is 1.5 times. And this is for adjacent rows of footings. Adjacent rows of footings with the clear spacing of less than 2B, it is depth of exploration is 4.5B. And likewise, the other specifications are given here. Pile and well foundation, so the depth of exploration is 1.5 times the width of the structure from the bearing level or bottom of the well. So that width is used for 1.5 times that width is used for the depth of exploration. So road cuts, it is actually the depth of exploration, bottom width of the cutting. Okay, that will be the depth of exploration. And here also the same, 2 meter below ground level or height of fill, whichever is greater. That is the case for fills. Spacing of borings, actually this is very important. The number and spacing of boreholes or trial pits will depend upon the extent of the site and nature of structures coming on it. For a compact building site covering an area of about 0.4 hectare, one borehole or trial pit in each corner and one in the center will be adopted. For smaller buildings, one borehole or trial pit in the center is adopted. This is actually a usual practice. So these are some of the borehole spacings given by the Indian standards. Highways, it is 300 to 600 meter. Earth dams 30 to 60 meter. Borrow pits, it is 30 to 120 meter. And for multi-story buildings, 15 meter to 30 meter. Single-story factories 30 to 90 meter. So now we will see some indirect methods, sounding or penetration test. So these are some of the equipments associated with the sampling. This is called the split spoon sampler. These are different photographs showing the same. So this can be halved into, and soil can be collected. You can see there is a cutting shoe which is kept here. This one is placed at this portion, placed at the tip of this tube, and it is driven into the soil. While doing the standard penetration test, this type of special equipments are used. This is sequences of standard penetration test. So it is actually a heavy weight is dropped on the boring tube, and it is driven into the soil. First 15 centimeter will be seating drive, and after that the engineer will count how much number of blows are required for driving 15 centimeter further, and then again 15 centimeter. So the total number of blows required for 30 centimeter depth is taken as standard penetration value, which is called capital N, standard SPT value. This is another way manually it is operated. So it is with respect to IS 2131 1981. The details are given in this Indian Standard Code, and this is the procedure adopted for doing the standard penetration test. And there are corrections also to be adopted, to be incorporated in the calculation of final N value. N value is termed as refusal if now 50 number of blows for any 150 millimeter penetration. The corrected N is given by this equation, provided it should be less than or equal to 2 times N. N is actually the value which is obtained from the field, and the correction is applied later on. Q is the effective overburden pressure in kilonewton per meter square. If there is water table, there will be a correction called a dilatancy correction is applied. Okay, for the case of fine sand and silt. N dash is equal to, that is the corrected N is equal to, this N is the correction value you got from this expression. Okay, the overburden correction is applied, and that value is substituted in this. For the case of N prime is greater than 15. For the case of N prime less than or equal to 15, you can adopt the same value. Okay, N prime is equal to N. You can take it directly. These are some of the correlations for SPT value. For cohesion-less soil, phi, this is phi, and the N value corresponding to the state of the soil, and the phi value is given in this. So correlations for SPT values for cohesive soil, the expression is given in this. So there are many advantages for this standard penetration test. So it is relatively easy to do. So there are numerous case histories available. Okay. So it provides the representative soil samples also. There are disadvantages for this. It is a very tedious process. Actually, it requires a borehole is required for doing this, and the dynamic effort is related to mostly static performance. Standards regarding energy are not uniform, because sometimes it is operated manually also.